Mm, I got coffee. We are full of energy and pumped today. Okay, if we were meeting together, today would be Projectile Day. Today is about projectiles, what they are, what they do, and how to calculate different kinds of projectiles and how far they go, and yada, yada, yada. All right, we are pumped and ready. Are you? Well, we being me, I don't know about you. I hope we are. All right, so here we go. On the board behind me and or in front of you, you'll see the word projectiles. Say projectile, anything under the influence of gravity. All right, anything under the influence of gravity, and we're talking about two-dimensional motion here. Now, so far, all the motion we've done, it's been just one dimension, okay? Just things dropping or tossing things in the air, and of course they come back down, or things moving horizontally. Those are one-dimensional motions. A projectile is going to be something which is dropped or thrown like that. Now check that out, look at it. That's two dimensions, right? That's two dimensions. Because what you've got is not only is the object boop, 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 going up, it's going forward, up and forward at the same time. And then the object gets to its peak, its pinnacle, its apex and or zenith of the flight, and then begins to boop, 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 come back down, but yet still go forward, down and forward. That is two dimensions, people. That is two-dimensional motion. And today we are going to discover the joys and fun and thrills of two-dimensional motion and projectiles. Only on the influence of gravity. Once you let go of it, that's it. Gravity's like, mine, mine, mine. And gravity takes over and says, thank you very much. So two things we got to know in order to be successful in our joy and fun of projectiles. Now, you don't have to believe either of these. You can believe whatever you want. If you want to believe that Santa Claus lives in the South Pole, that's fine. You can go ahead. You're wrong, but you can still believe it. He lives in the North Pole, and thank you very much. I do believe that. So you're entitled to your own beliefs, but not your own facts. So here are two facts that you should at least pretend that you understand in order to be successful in this unit with projectiles. Here they are. Horizontal motion is independent. That means doesn't depend on, okay, independent. Hermie was independent. I want to be independent. Remember Hermie? Hermie, who was a dentist, wanted to be a dentist, he was an elf. Rudolph the Red-Nosed Reindeer, 1964 claymation. Okay, great, special. Okay, Hermie, he was an elf, yeah. I want to be independent. Okay. Horizontal motion is independent of vertical motion, and vice versa. In other words, this motion boop, 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 has absolutely nothing to do with this motion. And then on the way back down, they don't care about each other. They have nothing to do with each other. They have no effect on each other. All right, we're going to demonstrate for you in just a minute here what I'm talking about. Second thing, an object launched and or drops, and you can do both. You can drop something which is moving, but you can launch something and drop it and launch it. Sound effects are important. From a moving object has the speed of the object that launched or dropped it. So in other words, if I'm running along and I've got this marker and I'm running down the road at 80 miles an hour, well actually let's get real, that's not realistic. Not as fast as I used to be. 65 miles an hour. And besides, I wouldn't want to break the speed limit anyways. So I'm running down the road at 65 miles an hour. And I let this go. Let it go. Let it go. And if I let go, what's it going to do? It's not just going to immediately drop from that point straight down. It has the velocity that I'm moving at. It's moving at 65 miles an hour if I am. And it's going to continue to move forward at 65 miles an hour. So, if I want to... Okay. This one's a little bit easier to go over than this one. So let's go over this one first. We'll start with the easier one, even though it's number 2. I could throw a 150 mile an hour fastball. Yes, I could. I know what you're thinking. You should be playing for the Red Sox. Well, two things. One, they don't let me. They actually pay me not to play because it's not fair to the rest of the players in Major League Baseball. And two, when I throw a 150 mile an hour fastball, it can be a little scary for the batter. I mean, not that it's moving 150 miles an hour of how I have to do it. Okay, so what I do is I get in my truck and I roll down the window, the passenger side window, Good thing I'm right-handed. And I take my baseball. Oh, actually, I have one here because I'm using one of my demonstration here in just a second. So I take a baseball, and I drive from center field toward the pitcher's mound, and when I get to the pitcher's mound, I am moving at 100 miles an hour. I got the truck flying 100 miles an hour. And then I throw the baseball at 50 miles an hour, which I'm perfectly capable of doing, and you probably are as well. 50 miles an hour. Those are vectors, remember? Velocity vectors in the same direction. The ball that I'm throwing, dropping, launching, has a velocity to the speed of the object that launched it. So if I am moving in my truck at 100 miles an hour, the ball is too. And in fact, all I had to do is just drop it out the window. I just drop it. I only have to just drop it. Boom. Ball, 100 miles an hour. So now, ball, 100 miles an hour, plus me, 150 mile an hour fastball. Look out, batter. All right, not only is a 150 mile an hour fastball, which I won't be able to control very much, but here comes my truck at 100 miles an hour. Okay, scary. You could do it though. We can all throw 150 mile an hour fastballs, not that hard. Of course, in the game of baseball, you wouldn't be able to do that, but still, shh, don't tell anybody. Okay, so I think we understand this idea that if I were just moving along and I let go of something, well, it already has the velocity that I let go of. So I like to ask this question. You say you're in a plane. Let's see if I can draw a plane here without erasing these. I can do it. I have faith in me. Okay, right up here. Yeah. So here's a plane. Okay, you see it, right? Yeah, I got skills. Yeah, drawing skills, physics skills, nunchuck skills, bow hunting skills, computer hacking skills. Napoleon Dynamite, yeah. There's my plane. And if the plane, let's say, has a cannon in the wing, and cannon is a thing that fires shells, like 20 millimeter shells out the front. And let's say the gun itself could, if the plane weren't moving, the plane is sitting on the runway, the gun could shoot these cannon shells at a velocity of 600 meters per second. I'll say the plane could fly at 800 meters. Well, no, that would be really unrealistic, but so what? Just go along with me. So let's say the plane can move at 800, let's go with miles per hour. Even for just a propeller plane, they couldn't go that fast. But still, just focus here for a minute, please. Plane could fly at 800 miles per hour. The cannon shells are fired from the cannon at 600 miles per hour. Okay, with me? So the cannon shells have a slower velocity than the plane itself that's firing the cannon. Now, if the plane are flying along at maximum velocity, it's moving along at 800 miles per hour, and it decides to fire the cannon on the wing here, it fires that cannon, and those cannon shells can be projected at 600 miles per hour. 800 is faster than 600. Would that plane shoot itself down? Some of you might be saying, yes. The cannon shells are moving at 600, the plane is moving at 800, so as soon as they leave the cannon, the plane will run into them and shoot itself down. No. Some of you might be saying, oh, well, no, because as soon as the cannon shells come out of the plane, gravity would pull them down. It would just pull them down, and the plane would just fly right over them. And so it wouldn't matter that the shells are moving slower than the plane, because they would just fall. No. Some of you get this. Remember, we talked about relative velocity. Person in a bus gets up and walks to the front of the bus when the bus is moving. A person from the side would see that person moving with a combination of those two velocities. Yes. The person in the plane, a person on the bus, would see that person move to the front of the bus at the velocity the person is walking. So a person in the plane, the pilot, would see those shells come out at 600 miles an hour. However, they are already moving at 800 miles an hour. They already are. They're in the plane. So they're moving at 800 miles an hour. And then if you fire them, the gun is able to produce another 600 miles per hour. So that's a combination of 1,400 miles per hour those shells would be moving at. So they'd be moving much faster than the plane. No, the plane's not going to shoot itself down. So not because they fall or not because of any other weird reason. This is why. The objects are being launched from something. It doesn't matter if they by themselves can move slower than the plane. They have a combination of those two velocities. Okay, all right. So it's very dangerous just to, if you just toss something out of a moving car at somebody, it's really dangerous because that thing is moving already at the velocity of the vehicle. Okay, so that was actually an easier one to kind of explain. I think most people would probably accept that. Hang on, energy burst. All right. Woo-hoo. This one, not so much. People sometimes have trouble grasping this. You might say, oh, I get it. I see what you're saying. But do you? Do you? You ready? I'm going to turn you around for a second. And we're going to go into the classroom here. Hang on. I got to turn you around. Well, I'm just going to have to turn you around because my button is gone on this. So there you are. You now see out into the classroom. All right, move you forward a little bit. I'm going to go back here. And I have, let me show you. 2 baseballs. One's a little more dirty than the other one, but they're 2 baseballs at the same volume, same size. They're both high school baseballs, so they have both the same weight. So they're essentially identical. Okay, one's a little darker than the other one, but it happens. This one got kind of dirtied up. But here we go, 2 baseballs. What we're going to do is the following. Okay, I'm going to drop this ball at the exact same time that I throw this ball horizontally, toss it horizontally at the same height. So I'm going to release them from the same height at the same time. Now this takes skill. Remember I said earlier, computer hacking skills, nunchuck. I forgot to mention projectile demonstration skills. Okay, got those 2. Here we go. I've been practicing for hours before you showed up. That's why I need the coffee to help me through. So I'm going to do this, and then you're going to see which one hits the floor first. Which one do you think is going to hit the floor first? Do you think it'll be the one that just falls straight down because it doesn't have to do as much? It only has to fall straight down. This ball's got to go sideways and fall down at the same time as I toss this horizontally. So there's going to be a horizontal toss. It's going to be traveling a longer distance, right? So that one clearly will be in the air longer than this one, which I just have to let go and drop straight down. Now some of you are rethinking, aren't you? Because you know me by now. You know that when I ask questions like that, and I say, well, this one clearly, you know that ain't the answer, right? You know. Okay, let's find out. We don't have to talk. Let's do the demonstration. The demonstrate. Let's see, where would this work? Where could you see me? Could you see it back here? Actually, I think you can. Or at least listen. Listen, you can at least hear. Okay? Which one hits the ground first? Okay, so I think this will work. So I'm going to toss this. This one will let go. And this one toss sideways, same time. Oh, I gotta get pumped up. Oh, I wish one of you were in class because I just go, take you and headbutt you and get all pumped. I wouldn't do that. No, without your permission, anyways. Okay, here we go. 1, 2, 3. Did you see/hear that? What do you think? What happened? What happened? I had the ground same time. They did. And if you can see it, you can hear it. I'm going to do it again. So some of you might be saying, well, you didn't toss this one fast enough. You toss this one faster. And therefore it goes faster and, it goes farther. It'll be in the air longer. Toss it faster. Okay. We'll give it a shot. Okay. All right. Let's see if I'm... Okay. 1, 2, 3. Crap. It went into the closet over there. Hang on. I got moved. The Patriots want me. Oh, but I'm saying, you know what? I can't. I'm signing my contract for the, MCC and my high school. So, sorry, Patriots. Maybe next year. All right. So, what did you see? Hopefully, you saw something, and hopefully, you heard it, if anything. And that was they both hit the ground at the same time. Now, you're saying, well, yeah, it's just a silly experiment. You couldn't distinguish because you didn't saw it fast enough. Okay, all right. After you're done watching this video, click on the one below. You don't have to believe me because, I'm not trustworthy. One, I usually wear a tie. Don't trust those people. Two, I'm wearing this shirt. Don't trust this person. But you would trust Mythbusters. They got street cred. Yeah, you'll believe them. Watch that video and see what happens. Because some of you might be thinking, oh, what if you took a gun? Like you had a bullet. Yeah, you had a bullet. Yeah, and you had a bullet. And you took a gun, you put a bullet in the gun, same caliber, same bullet. And from the same height, you held up the gun. And this, by the way, I wanted to try to do this in school. They weren't keen on the idea. Okay, I think we know why. So they didn't let me. Okay, but Mythbusters can do it, and they fire the gun, and so same height, same time, boom. Which one's the ground? Well, clearly the one falling straight down. The gun's guys can go a long way. Wrong. Don't believe me? Check out the video below. They did that experiment. Watch the results, people. Okay, so you may not believe that something being thrown, tossed, fired horizontally at the same time something is dropped, you're going to hit the ground at the same time. But at least pretend you believe it, so you'll be successful at the problem solving we have to do. That's what this means. This motion has nothing to do with this motion, which is due to gravity. Gravity doesn't care how fast you are moving sideways. Gravity doesn't care. I always say gravity does not discriminate. It doesn't care who you are, where you're from, what you like to eat, and what your favorite movie is. Gravity doesn't care. As soon as you give gravity a chance, 9.8, baby. Boom. So as soon as I release that ball, gravity's like those birds in that movie with the fish. Mine. Some of you get it. As soon as I let go of that, gravity like, mine, 9.8. As soon as I let go of this one, gravity says, mine, 9.8. 9.8, 9.8. It doesn't matter. Gravity doesn't say, oh, well, you're moving sideways, so, you have a harder job. So I'll take it easy on you and maybe only pull you down at, 5 meters per second. Gravity doesn't care. Okay, 9.8, 9.8. So at the same time, we're going to hit the ground because gravity is the thing that's affecting both of them at the same rate. Again, this has nothing to do with gravity. All right? I hope we've cleared up these misconceptions that you might have had. And I hope that some of you are going, oh man, that doesn't make sense to me, man. I don't get it. My brain hurts. Good, because I always say, do physics, not drugs, okay? Let physics make your mind go boom, boom, and open your horizons. That's what I'm here for, people. I'm here to educate you. So, again, this video, we'll bring this one to a conclusion. We'll start doing some problems in the next one, but check out the Mythbusters. They've done this. And I put the short version in for you to see the results. Okay, remember, don't believe me, don't trust me, but trust the Mythbusters.